Is 2.3 problem 10 discussion. Let's read the problem. Find the first three consecutive terms in GP whose sum is 7 and sum of the reciprocals is 7 by 4. It's very similar to what we have done in the past, but there is a small difference. I will show it to you. Okay, let's mark what's given in the problem. Same thing, it's a GP, three consecutive terms. Their sum is 7. Okay, earlier we had product as 7, okay, and sum of the reciprocals is 7 by 4. Okay, and let the three, okay, this is what is given. Sum is sum of the terms equal to 7, sum of the reciprocals equal to 7 by 4. Okay, what are we asked to calculate? We are asked to calculate the three consecutive numbers. So let the three numbers be A by R, A and AR. Okay, so now we'll add them up. So A by R plus A plus AR equal to 7. So what will happen? If you take A commonly out, you'll get 1 by R plus 1 plus R equal to 7. That on simplification, you'll get one quadratic equation, but let's keep that by the side. Then what we say is sum of the reciprocals equal to 7 by 4. That is, the reciprocal of A by R is R by A. Reciprocal of A is 1 by A. Reciprocal of AR is 1 by AR equal to 7 by 4. Here again you can take 1 by A commonly out and you'll get R plus 1 by R. That's what you got here also. Okay. Then all we need to do is just solve those two equations 1 and 2 and get the values of A and R. Once you get the values of A and R, you will be able to get the three consecutive numbers. You remember A and R, two unknowns, two equations, which means we will be able to solve it. Okay, it's more of a simplification problem, which I'll show it right to you right now. Okay, the sum of the terms 7, sum of the reciprocal is 7 by 4. We are assuming the terms to be A by R, A and AR. So A by R plus A plus AR equal to 7. Take A commonly out. You will get 1 by R plus 1 plus R equal to 7. Okay, and you take R LCM, so it will become A into 1 plus R square divided by R equal to 7. This is equation 1. Equating the reciprocals to 7 by 4, we get reciprocal of A by R is R by A is 1 by A, AR is 1 by AR equal to 7 by 4. So take 1 by A commonly out, you will get R plus 1 by R equal to 7 by 4. Actually, you can jump everything and you can do this here also. But since I've done it this way, I will explain it both ways. If you see, both of them are same. 1 plus 1 by R plus R. So if you divide these two, okay, you will get A square will be equal to 4 and A will be equal to plus R minus 2. That's what you'll get. But anyway, since we have taken LCM here, you take LCM here also. So what will happen? R square plus 1, R plus 1 will be equal to 7 by 4 when you take LCM for this thing. Now you divide equation 1 by 2. You can see it's the same here. 1 plus R square. Here it is R square plus R plus 1, which is the same. Okay, so you can divide this by this. So you will get A divided by 1 by A, which will become A square. And 7 divided by 7 by 4 will be equal to 4. Okay. So dividing 1 by 2, you get A into 1 plus R square by R. But when we divide, it becomes a reciprocal, right? So into A, R by R square plus R plus 1, right? So if you see, it's the same. When you divide this by this and you convert it into multiplication, this will become a reciprocal. Instead of R square plus R plus 1 by R, it becomes R into R square, multiply R by R square plus R plus 1. Okay, so it's a reciprocal which gets multiplied. So you see these two will get cancelled and A into A is A square and 7 and 7 will cancel. A square will be equal to 4 and A will be equal to plus R minus 2. But we have to reject minus 2 for one simple reason, because if A is minus 2, then your numbers, the three numbers are likely to be negative, but they have given the sum to be sum and the reciprocals are positive. So which means we cannot take a equal to minus 2, we have to take a equal to 2. Okay, substituting a equal to 2, we get in equation 1, right? What is equation 1? That is 2 into a into 1 plus r square by r equal to 7. So substitute a equal to 2, you get 2 into all these things. And so 2 into 1 plus r square will be 7, will go to our side, it will become 7r. So you expand this to 2r square equal to 7r. That brings 7r this side, it will become 2r square plus 2r minus 7r, that will be minus 5r, okay, and plus 2 will remain the same, equal to 0. Now this quadratic equation needs to be factorized, and the number is the constant into the coefficient of r square. The two 2's are 4, that 4 can be split as minus 4 into minus 1, and minus 4 minus 1 equal to minus 5. You got it? So this minus 5r must be written as minus 4r minus 1r, that is r. Okay, so that's what is done here. 2r square minus 4r minus r plus 2 equal to 0. So from these two you can take 2r commonly out, so it becomes r minus 2, and you want to get the same r minus 2 here. So to get same r minus 2, you have to take minus 1 commonly out. So minus 1 if you take, this will be r and this will become minus 2. So that's what minus 1 into r minus 2. So take r minus 2 commonly out, you will get 2r minus 1 into r minus 2. Okay. So when you take r minus 2 commonly out, you will be left with 2r minus 1. Sorry. Okay. Now, the product of two terms equal to 0, either one of them will be 0. So when this is 0, r equal to 2. When this is 0, 2r will be equal to 1 and r will be equal to half. So r has got two values. Now if you recollect, had we taken it as minus 2, okay, so this is not going to work out this way. So that's the reason we rejected that minus 2 there. Okay, so when a equal to 2 and r equal to 2, we get the three numbers as a by r. 2 by 2, that is 1. Then a, it is 2. Then ar, 2 2's are 4. And in the second case, when a equal to 2 and r equal to half, a by r, 2 divided by half is 4. And then a is 2. And then a into r, 2 into half, 2 and 2 will cancel, so it will become 1. So the two series or the two options of the three numbers are 1, 2 and 4 or 4, 2 and 1. You got it? So what I'm suggesting is that pause the video, try to work this problem on your own and then come back and check the solution. It's little difficult, as I said, the conditions are easy to frame, but it is more of a simplification exercise. Okay? Thanks for watching this video.